Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about how to make a point and click system inside of Godot 4. Now, I know I previously covered this in a navigation tutorial, but some things have changed because the Godot developers really like to mess with the code and really like to change a lot of things. So hopefully this time they don't change anything. I don't have to make another update video, but we're going to talk about how to build one. So we're going to go through the process of getting a point to click system working. So we're going to raycast from your camera to your ground and getting the position of that raycast, and then we're going to set up your navigation agent, set up how we're going to move towards a point, and we're going to talk about how to make it so that your character faces the correct direction when they're walking towards your mouse. That's what I have in store for you guys today. Let's go ahead and get started. Okay, so the first thing we need to do is we need to set the scene. We actually need to build out how we're going to do this point to move system. So first, we're going to create a 3D scene. We're going to right click, add a child node, and let's add in a navigation region. Now, a navigation region 3D allows us to use Godot's built-in navigation system. And that's basically what we're going to use to move our character around. Now, to have navigation, you need to have some kind of navigation mesh, which is right over here on the right. So we'll click on this and we'll click on new navigation mesh. And you'll see there are a bunch of options here. And for the most part, we're not going to touch any of the options. We're just going to use them as default for right now. Although if you guys have any problems, check out all these options and take a look at them. There are so many things here that can help make your level a lot better and easier to move around in. So be sure to check it out. Now, for navigation to work, you need to have some kind of mesh for it to use for navigation. So we'll come over here, we'll right click, add in a child node, and we're going to add in a mesh instance 3D, and we'll click on empty, and we will add in a box mesh. Now, I'm going to scale this guy down. So we'll go into our little scale tool. I'll scale this guy down like so. And I'm going to scale it up to be something decently large, something like that. And I think that will do for this specific tutorial at least. And then for navigation to work, if we come back to our navigation region and click bake, you'll see that it kind of works. We actually have our navigation region, but it's never good to have meshes that don't have collision. So we'll make some collisions. So we're going to right click our mesh 3D. We'll add in a child node. We'll add in a static body 3D. And for static body 3Ds to work, we need to have some kind of collision. So we're going to right click that, add in a child node, and let's add in a collision shape 3D. And then for our shape, we will add in a box shape. And you're going to see that it will automatically size to match our mesh. And that's why I did it in that specific order, is because if you do that in this specific order, it will automatically size your box for it to match, which is really, really nice. Now, if we click on our navigation region 3D and we click bake mesh, you'll see that we have ourselves a basic baked mesh. Now, I don't really like how far it is above the ground. So if we go into our cells and we change our height down to something like 0.1 and we click bake, you'll see that it is put right down onto the ground level of this object. And that's pretty much all we have to do to set up our basic scene. And now we just have to build out our character that we're going to be moving around by clicking. So the easiest way to do that is to right click our node 3D, add in a child node, and let's add in a character body 3D. We're going to right click that, add in another child node, and we need to be able to see our mesh. So we'll bring in a mesh instance. So we'll do a mesh instance 3D, and we're going to make that into a capsule mesh. Now I'm going to drag this guy up, and we might need to make our ground a little bit bigger. It's a little on the tiny side, but that's okay. We'll burn that bridge when we get there. If we right click our character body 3D, we add in a child node and we add in a collision shape 3D, and we make it into a capsule shape. We'll just drag this guy up like so. And there we go. So now we have a very basic character with a collision shape. And the reason why I'm adding collision, because you don't necessarily need to have collision for this, is because it's a good idea to allow your character to have collision. It allows him not to run into walls and things like that. So it's always a good idea just to have it just in case. Now, for our character to be able to move around, we need to have a navigation agent for our navigation system. So we're going to right click our character body, add in a child node, and let's add in a navigation agent 3D right here. So we'll bring that guy in, and that will allow us to have pathfinding. It'll allow us to actually navigate our character. Now, in this case, I'm going to come into my navigation region 3D. I'm going to grab my mesh instance, and I'm going to scale this guy up just a bit more to give me a bit more space. And now we need a camera for us to be able to see this, because right now we don't have a camera. So if you don't have a camera, you're just going to get a 2D view of the scene. You'll get something like this, and it'll probably be something like this-ish, and you're just not really going to see anything. So we need to add a camera to our scene. So let's right click our node 3D. Let's add in a child node. Let's add in a camera 3D. And then I'm going to drag this guy back. I'm going to scale it. I'm going to rotate it down a few degrees. So something like that. We'll just kind of bring this guy here. Let's click on preview and take a look. I think that'll be good for the specific tutorial we're doing. But if you guys want to change your camera angle, of course you are welcome to. Now, if we right click our character body 3D and we attach a script and we change our template to node default and we change this to click to move.gd and we hit enter, you will see that we have a ready and a process. And if you're not familiar with Godot, ready runs when the application starts. So when your game starts, and process runs every single frame of your game's execution. So that's something to keep in mind. So the first thing we need to do is we need to get a reference to our navigation agent. Now we can actually do this on ready by just hitting @onReady var navigation agent $equals $, and we need to pull our navigation agent. So if you look right here, you can see it's called navigation agent 3D. So navigation agent 3D. And that should be all we will need. So next, all we have to do is add in an input function. So we'll say func_ input event. And that is going to fire off an event anytime we do some kind of input. And what we'll do is we'll check if input is action just pressed left mouse. Now, I know you guys probably don't have left mouse. That's because I didn't delete this when I re-recorded this tutorial. So how I set this up is if you come up here to your project settings, and you go into input map right here, and you add a new action. So you type something like left mouse and you hit enter. It's going to add in one of these guys. And then if you come over here on the right and you click on the plus icon, it'll say listening for input. If you just click, it'll say left mouse button and you can hit OK. And that will add the left mouse button to your event listener. And then you can click close. Now, once you have that, we need to get a reference to our camera because we're going to be firing a ray from our camera to our actual ground, if that makes sense. So we'll say var camera is equal to, and we got to get a reference to our camera. And this is where things are going to get complicated because we can't just say, well, give me a camera. And you can do this in a lot of different ways, but the easiest way I like to do it is just by making a group for my cameras. So I'll come into my camera 3D. I'm going to go over to our node and I'm going to click on groups and I'm going to add in a camera group like that. And then I'll just come in here and I'll say get tree dot get nodes in group quote camera. And I'll pull back the first reference, which should be my camera. And now we need to say from where we're projecting that ray. So when you do a raycast, you need to say where from, where to, and then you need to cast that ray cast, if that makes sense. So now we just need to get our mouse position. So we'll say var mouse pause is equal to get view port dot get mouse position, and that'll pull back my mouse position. And now I need to set some kind of ray length, and that's basically going to say how far we're going to do our raycast. So var ray length is equal to 100. And then we need to actually set where we're going to raycast from. So for a raycast, you need a raycast from to, and then you need to kind of set up a space state and then fire off a ray query, okay? And I know that that's a lot, so we'll walk through it slowly. So first we have to get our from. So var from is equal to camera dot project underscore ray underscore origin. And we'll need to pass in a position of some description. So we'll put in a mouse position, okay? Then we have to fire to. So we'll say var to is equal to from plus camera dot project underscore ray underscore origin. And we'll pass in our mouse position. And then we'll multiply that by ray length. And what that's going to do is it's going to say, okay, we're going to project from and we're going to project to based off of our ray length. So we're going to add the two together and then fire off a ray length. Okay. And then we need to tell it what space we're going to be doing this raycast. So var space is equal to get world 3D dot direct space state. And then we need to do a ray query. So var ray query is equal to physics ray query parameter 3D dot new. And the reason why we're using new is that's how you instantiate a object class inside of Godot. So if you do dot instantiate, you're instantiating it in the world. But if you do dot new, that's creating that class and saying, hey, this class now exists. And now we can fire off our ray query. So ray query dot from is equal to from ray query dot to is equal to 2. And then we're going to do our raycast. So var result is equal to space dot intersect ray query. And then we can print our results. Okay. Now this is a whole lot of stuff here. So let's kind of step through this nice and slowly. So first we're getting our camera because we need to know our camera and make sure that we have a camera. Then we're getting where our mouse is located on the screen in an XY value, so a vector 2. Then we're setting our ray length. So how far from our screen are we willing to project? So if you wanted to say you could only click the top of mountains, right? You might want to make that something like a 5 or a 10, right? But if you want to project basically infinite, you could set it to 100,000, and that means that that ray would shoot 100,000 units before it says, hey, there's nothing here. So that's kind of the nice thing about this raycast is that you can make it as long or as short as you need. I put it as 100 because I felt like that's a good number, but it's up to you. And then once we do that, we're basically saying, okay, we want to project a ray from our mouse position based off of our camera. So this is basically translating the camera space, if that makes sense. Translating the 2D space to 3D so that it can be projected. And then we're setting this to. So we're saying, hey, basically take our from, add it to our to, and then go by our ray length. So that way we can come back with how far and where we want to do this, if that makes sense. And then this is our space. This is saying which space state do we want to be in? Do we want to be in 3D or 2D? And in this case, since everything here is a vector 3, it's going to be a 3D space. And then we're building a ray query. And a ray query basically describes what your raycast is and how it works. And then we're saying, I want you to fire a raycast from this location to this location. And then I want to get back my results by running an intersect ray. So we're saying, hey, fire off this ray, get whatever it's intersecting, and then come back to me. And if you have any questions, leave them in the comments below and I'll explain this in more detail if you need. So now if we just hit play, you'll see that it's going to come up and say, hey, you need to save. So we'll say test move.tscn and you'll see that we now have our scene here. If I click, you'll see we get back, well, nothing. So that's not a good sign, but it's better than nothing. So let's see what's going on here. So first things first, we need to see if we're getting back our camera. It looks like we probably are. So if I put a breakpoint here, let's see what happens. If I click, we have a camera. We have a mouse position. We have our rake length. We have our from, which is good. We have our to, which is also, I think, good. We're getting back our space state, and we have a ray query is equal to. Did I make a mistake? I did. There we go. We're adding a physics raycast query. We're doing a raycast. We're firing off our ray query, making sure that that's good. Our result is empty. So the question is, do I need to have it intersect with areas? So let's try that. So ray query dot collide with areas is equal to true. I don't think that's going to change our result any, but we can try it and see what it does. So we'll click play. We'll let this run through real quick. Did it come back with anything? That's a no. So something is wrong with our ray query. Oh, I think I figured out what's going on. So we have a project ray origin here, and I'm pretty sure we're supposed to use project ray normal instead. Now, the reason why, and let me check, actually, let me test this real quick beforehand. And there we go. We're getting back some stuff. That's good. Okay. So what's going on here? Hey guys, Editor Mitch here. So to explain this a little bit better, basically what we're doing is we are getting our ray origin, which is basically like our camera 0 location. And then we're firing off a ray along our normal. And a normal is basically a straight line from our camera wherever our projected ray origin is. And it's firing from there to wherever our mouse position is located. And it's firing it based off of a distance of whatever our ray length is. And then we're basically just saying, hey, direct space state, that's the space state that we are currently using, which is our 3D world. So we're saying we're going to use a 3D raycast, and then we're going to fire off a 3D raycast. We're building up a little query. We're grabbing our from, we're grabbing our to, and then we're saying, hey, we want to collide with areas, which this is optional. You don't actually need this. And then we're firing off our raycast and getting back our results. So that's basically how it works. Anyway, get back to the video. So now that we have our results printing, you can see that we have a bunch of options here. So we have our position, our normal, we have our collider ID, what the object is, the shape, and the RID. So if you wanted to pull back information about that object, for instance, if you clicked on something like a enemy or something and you wanted to pull back information which enemy it was or something like that, you could pull back the collider and get the parent and you'd be able to pull that data back. But in our case, we're just going to be moving our character based off of wherever we click. So really all we need is our position right here. Now in navigation, when you move an object, you need to set its target location. Okay. And so all we have to do is come in here and just say navigation agent dot set target underscore location, and we can just pass in our result dot position, and that will return this position value for our character's target location. And now all we have to do is set up our movement system. So basically, how are we going to move our navigation agent? And to do that, all we'll do is come up to our process. We'll come in here and we'll just say if navigation agent dot is navigation finished, we will want to return. Now, the reason why we're doing that before we do anything is basically saying, hey, if we've reached our destination, we don't need to do anything. We're good to go. Now, how I like to code is I like to create functions to do my bidding, basically. I don't want to put all my movement code inside of here. If you want to do that, you can. Just follow my function just right here, basically. But I'll come in here and I'll create a function. So I'll say func move to point. And I'll pass in my delta, speed, and I will go ahead and start coding. Now, our move to point, all it's going to do is it's going to take in a target position. It's going to take in, all it's going to do is grab its target position, which direction it's trying to move, and then it's going to move in that direction. We'll just say var target position is equal to navigation agent dot get next location, like that. And then we will get our direction. So var direction is equal to global position dot direction to, and we're going to pass in our target position. And then all we have to do is move our character. So velocity is equal to direction multiplied by whatever speed we want it to be. And then we'll just move and slide. And that'll allow us to move. So what we're doing here is basically once we click, we're setting our next target location. So we're just saying, hey, I want you to go here. And then every single frame, it's going to move to point, and it's going to get the next location it needs to move to. And then it's going to grab the direction of our next target position by grabbing this global position and then looking for the target position. And then it's going to push us towards that position. And then all we have to do is come in here and type move to point, and we'll pass in our delta, comma, and then for our speed value, we can set it to whatever we want. If you want to put it at like 100 or 1,000 or something like that, you can do that. In my case, I'm just going to come up here. I'm going to go var speed, and I'm going to make that equal to 5, and then I'm just going to pass in speed with a capital S, like that. And if we've done this correctly, it should work. So if we hit play and we click, well, we have a crash, so that's not a good sign. We also cannot see our character, so that's something else we're going to have to fix. So first, to fix our crash, let's take a look. If we look at our crash, let's see. Non-existent function set target location on base navigation agent 3D. So that's never good. That means that our set target location does not exist. And let me see if I can get auto completion to help me out here. So I'm going to make this a type navigation agent 3D. And I'm going to see if that's going to give me a bit more leeway here. So set underscore target. It looks like they changed it to dot target position is equal to, and then result dot position. I just did this tutorial like a couple days ago before RC came out, and it was set target position, but now it's target position. So it looks like they did some changes there. So now, hopefully, if we hit play and we click, you'll see we have another crash. It looks like get next location doesn't exist. So my guess is, judging by the previous thing, it's probably next location or possibly dot get next path position instead. So that's some of the things to keep in mind with beta software. So it's always funky because they always change it on you. So originally it was get next location. Now it's get next path position. So we'll try that one more time. And there we go. Now you can't really tell if it's working or if it's not. So how do we know if it's working? Well, if we right click our node 3D, we add a child node, and we add in a world environment. We click on our environment, add a new world environment, and let's add in a sky. Let's add in a new sky, and let's make it a procedural sky. And that should allow us to see our environment. So now if we click, you'll see they move to our location, which is awesome. That's great. That's exactly what we wanted. Now, there are some things that are a little weird. First, they're not quite going directly on top of it. If you've noticed, it just it gets close to my mouse. It doesn't quite land on top of it. And the reason why is because if you look at your navigation agent 3D, you can see that it has a path desired distance and a target desired distance. You change this to something like 0.1 and you change this guy to 0.1, and then you try that again, you'll notice that if I hit click, it now goes directly onto my mouse position. And that's something to keep in mind. Sometimes you'll need to adjust these little values here to kind of make your stuff work for you. Something else to note, if we take a look at our character here, we zoom in on him real quick, you'll notice our navigation mesh never updated when we scaled all this up. And that's because the navigation mesh doesn't update on runtime. It updates one time. So if we click on our navigation region, we click bake, you'll see it's now updated and it's full sized. Also, something that you can't tell is our character actually facing the correct direction? And the easiest way to know that is to add in another mesh object. So we'll add in a mesh node 3D. We're going to add in a capsule mesh. We'll rotate this guy 90 degrees and we'll pull it up like this and we'll put it out like this and give him a nice big fat nose like so. We'll give him a nice big nose like that. There we go. Something that's really easy to be seen so we know if he's rotating. And we'll hit play. We'll click and you'll see that, well, he's not rotating at all, right? So how can we get him to rotate to the proper direction? Well, that's really simple. All we have to do is go back to our script and then we can add in another function. So I'm going to add in a function called move face direction. And we'll pass in direction like that. And what we'll say is look at, and we'll tell it to look at something. Now, to do a look at, you need to have a vector 3 for it to look at, right? The direction that you want it to look at. So we'll say vector 3, and we'll pass in direction.x, comma, and we'll need to give it some kind of y value. Now, we don't want it to be our direction y because that's going to make him look down at the ground. So we'll say global position.y, comma, direction.z. And then we need to tell it which direction is up. So we'll say vector 3 dot up. And that will tell it to look at that direction and it'll tell you which way is up, basically. And then we'll just pass in face direction and we will pass in our direction that we previously grabbed. So we'll pass in our target position like so. Now I know what you're thinking. Well, why not the direction? And the reason why is because you want them to look at the point that they're walking to, not the general direction that they're walking to. And I know that seems kind of weird, but trust me, it makes sense. If we hit play and we click, you'll see that, well, that kind of worked, but not quite, right? It seems almost like it's offset by 90 degrees. And it is. So if we go back to 3D and we take a look, Godot does everything with a Z positive value, if I remember correctly. It's either that or it's a Z negative value. So we'll put this in the front this way and let's see if that worked. Nope, so it's a Z negative value. My apologies. I always forget. It's one way or the other. So we'll put it this way and then we'll hit play. And you'll see now the character looks in the direction that we want it to look. Awesome. And that's pretty much how you create a click to move system inside of Godot 4. Hopefully it doesn't change anymore, but if it does, I will make an update video. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I am here to make content for you guys. This video was a viewer suggested video, so if you have any suggestions, please leave them in the comments below, and I'll be more than happy to get to them. Now, I know that some people have been asking me about the horror game, and yes, I am continuing it. It's just been really busy over here. I had to fly out to California for some business, and we're in release cycle, so everything has been just up in the air for me, so it's been kind of a mess the last few weeks. So hopefully things will settle down, and it'll allow me to concentrate on YouTube again. But right now, it's just kind of a really hectic time for me. And hey, if you guys have any questions or any comments, throw them in the comments below or jump on my Discord. Link is in the description, and I'll be more than happy to help you out with any issues that you might run into. Like I said, it's been a little hectic, so I haven't had the time to kind of go through and help people out. But there are a lot of people on there that are willing to help you out and are willing to work with you. But that is all I have for you guys today. So thank you so much again for watching, and I'll see you all next time. Thanks.